Okay, notice we have the unit circle. In the unit circle, that means we have a circle with a radius of 1. So anywhere from the center to the edge of this circle is exactly 1 unit. So today I want to discuss objects in motion. How can we move a point around the perimeter of this circle? So all points that we move will be on the circle, which means on the edge exactly 1 unit from the origin. So the first thing I want to consider is rotating 45 degrees. For a rotation of 45 degrees, I'm going to multiply by the points that are at 45 degrees on the unit circle. So radical 2 over 2 is your x-coordinate. Radical 2 over 2i is your y-coordinate. So we start at the origin and we rotate 45 degrees. And we get to the point radical 2 over 2 plus radical 2 over 2i. Now we're going to replicate this process from the point here. So I'm going to take this value, radical 2 over 2 plus radical 2 over 2i, and multiply it by itself, like so. When I do that, my result is actually I. And that gets me to 90 degrees, which is also the point 0 plus I. Now I'm going to take this point and again multiply by the same value, radical 2 over 2 plus radical 2 over 2i. This is a rotation of 45 degrees. When I do this, I get to this point, 135 degrees, also known as negative radical 2 over 2 plus radical 2 over 2i. Another 45 degrees gets me to the point 180 degrees, which is negative 1 plus 0i. I continue the process all the way around the unit circle. Multiply by radical 2 plus radical 2 over 2i. This brings me to 225 degrees, which is the point negative radical 2 over 2 minus radical 2 over 2i. Remember, in the third quadrant, everything is negative. So how did I get here? The same thing. I rotated another 45 degrees. My next rotation brings me to negative I, or 0 minus I, which is 270 degrees. One more rotation gets me to 315 degrees. From this point, I rotate another 45 degrees, and I'm back to the origin. So I just made a complete trip around the unit circle using rotations of 45 degrees. And the key here is a rotation of 45 degrees is multiplying by radical 2 over 2 plus radical 2 over 2i. Now I want to continue the same process again. So we're going to go all the way around the unit circle, but this time we're only going to go 30 degrees. Now, if you know your unit circle, you know what the cosine and sine of 30 degrees are. If you're not sure, just take the cosine of 30 degrees, then take the sine of 30 degrees. So to go to 30 degrees, we're going to multiply by radical 3 over 2 plus 1/2 I. And in my graphing calculator, what I do is store this point as Z2 because I stored the 45 as Z1. So when I'm doing these calculations and you're seeing this on your screen, all I did was put this value in the calculator to store as Z2. That's how I get my 30 degrees. And my movement, I just multiply Z2 by my new point to get to the next point. So I'm not having to type this in for Z2. I'm storing it in the calculator. So as I store it, now I use it. So when I have this point times this point, it gets me to this point. So what I'm actually doing is rotating only 30 degrees. So I'm multiplying by radical 3 over 2 plus 1/2 I. When I do that, notice that, ironically enough, these two things actually trade places. So the 1/2 becomes my x-coordinate, and the radical 3 over 2 becomes my imaginary coordinate. Now I do it again. This time I'm going 30 more degrees, so 30, 60, and then 90. When I multiply this point times the 1/2 plus radical 3 over 2i, I actually get 2i. And 90 degrees is the point 0 plus i. Now, 30 more degrees, multiply this point times I, and I come here. And that is the coordinates of this point at 120 degrees. Now we start the process again. I take this point and I rotate it another 30 degrees. So notice I'm always taking my Z2, that's my transformation, that's my rotation, and multiplying it by the point I have. And that's the coordinates of 150 degrees. So I take this point, that's Z2, and multiply it by the point at 150 degrees to get to 180 degrees, which is -1 or -1 plus 0i. Working my way around the unit circle, we come to negative radical 3 over 2 minus 1/2 I, which is actually 210 degrees. So I want to rotate another 30 degrees from here. That gets me to -1/2 minus radical 3 over 2i, which is also 240 degrees. I multiply radical 3 over 2 plus 1/2 I by this point. When I do that calculation, we get -I, which is 0 minus I, or 270 degrees. Another rotation of 30 degrees brings us to 1/2 minus radical 3 over 2i, and that is 300 degrees. As we move around the unit circle, we get to 330 degrees, and one more rotation completes the unit circle. So I want to show you how to use the calculator to make sure you're able to do this yourself. First thing we want to do is go to Settings, Document Settings, and look at Real or Complex. Here, we're not using cosine and sine, so we don't want polar coordinates. we want rectangular coordinates. That's still in complex mode, but it's rectangular coordinates. Say okay? Back to our calculator page. Now, I know that 30 degrees on the unit circle is the point radical 3 over 2. So I'm going to do control divide. Radical 3 over 2. Get out from under the fraction. Plus, control divide again. 1/2. And here we need the I. This is important. If we're going around the unit circle, this is an imaginary number. If I don't have i's in here, nothing's going to work. Now, the store command. It's red on my calculator. So I have to use the control key followed by the store command, which is right above the variable key. STO with an arrow, and that's my store. I just named this point Z number 2 and press enter, and that stores that point in the graphing calculator. So let's say that I want to do this Z2, and I'm going to translate 30 degrees from any point on the unit circle. I'll just pick 60 for now. Parentheses, control divide, 1/2 plus, control divide again, radical 3 over 2. Now, when you do this yourself, the biggest mistake that you might make is to forget to put this in parentheses. If you don't have the parentheses, you're going to do Z2 times the 1/2, but you won't get the radical 3 over 2 with the I. Enter. See, that's where sometimes I forget that the calculator doesn't understand that parentheses mean multiply. So you do need the times symbol after your Z2. And that's how you use the graphing calculator to rotate points on the unit circle.